Hello everyone, myself Neelakanta. I am studying in Sri Venkateshwar College of Engineering in Bangalore. I am from CSC department. Today I am going to discuss the subject about mathematics. In this subject, the specific topic is Markov analysis. Markov analysis in linear algebra. Markov analysis is a powerful tool in linear algebra used to model and predict the behavior of systems that evolve over time in a probabilistic manner. It has a wide range of applications in various fluids, including finance, biology, and music generation. Introduction to Markov processes. Definition of Markov process. A Markov process is a mathematical model that describes a system's transition between states based solely on its current state, independent of its past history. It's characterized by the memoryless property, meaning that a future state depends only on the present state, not on any previous state. Examples: weather patterns, stock market fluctuation, and the movement of particles in a fluid can be modeled using Markov processes. These processes are widely used in various fields due to their ability to capture the stochastic nature of complex systems. Probability transition matrices. A probability transition matrix is a key component of a Markov process. It represents the probabilities of transitioning from one state to another. Each entry in the matrix corresponds to the probability of moving from one row to the column state. And next one is Markov chain dynamics. And first one is iteration. A Markov chain is a sequence of states where the system transitions from one state to another state based on the probability transition matrix. The dynamics of the chain can be analyzed by iterating the matrix and observing how the state probabilities change over time. And second one is steady state. In some cases, the Markov chain reaches a steady state distribution where the probabilities of being in each state stabilize over time. The steady state represents the long-term behavior of the system. And next one is eigenvalues and eigenvectors of Markov matrices. Eigenproperties. Markov matrices have specific property related to their eigenvalues and eigenvectors. The largest eigenvalue of the matrix is always 1, and its corresponding eigenvectors represent the steady state distribution of the system. Stability analysis. By analyzing the eigenvalues and eigenvectors, we can understand the stability of the system. If all eigenvalues are less than 1, the system will converge to the steady state over time. And next one is regular Markov chain. Definition of regular Markov chain. A regular Markov chain is a type of Markov chain where it's possible to reach any state from any other state. After a finite number of the transitions, this property ensures that the chain will essentially converge to a unique steady state distribution. Convergence time. The time it takes for a regular Markov chain to converge to its steady state depends on the structure of transition matrix and the initial state of the system. In some cases, conversations can occur quickly, while in others, it might take longer. And second one is application of Markov analysis. In this application, the first one is finance. Markov analysis is widely used in finance to model stock prices, analyze credit risk, and predict future finance performance. It's a powerful tool for understanding and meaning finance uncertainties. And second one is biology. In biology, Markov chain are used to model the evolution of species, predict the spread of diseases, and simulate the behavior of molecules. It provides insights into complex biological systems. And third one is music generation. Markov analysis is also used in musical composition, where it can learn patterns from existing music and generate new compositions that mimic the style of a particular composer or genre. It allows for the creation of unique and innovative musical pieces. And next topic is generating music compositions using Markov chains. Learning patterns. Markov chain can be used to learn the patterns of musical sequence such as notes, chords, or rhythms by analyzing a large corpus of music. This process involves the building a transition matrix based on the observed musical patterns. Composition generation. Once the transition matrix is built, the Markov chain can be used to generate new musical composition by randomly selecting state based on the probabilities defined in the matrix. This process results in music that mimics the style and characteristics of the training data. And next topic is limitation and assumption of Markov analysis. The first one is stationarity. One key assumption of Markov analysis is that the transition probabilities remain constant over time. This assumption might not hold in real world systems where the probabilities can change due to external factors. Second one is independence. Markov analysis assumes that the current state is independent of past states. These assumptions might be violated in systems where past events influence the future state. And third one is data quality. The accuracy of Markov analysis depends on the quality and quantity of data used to train the model. Limited or inaccurate data can lead to unreliable predictions. In this topic, last is conclusion and key takeaways. Markov analysis is available tool for understanding and predicting the behavior of systems evolving over time. Its ability to model and analyze the probabilistic processes has made it widely applicable across diverse fields However, it's crucial to the aware for its limitation and assumptions to ensure accurate and reliable results. Thank you.